Bismillah ar-Rahman ar-Rahim. In this session, we will discuss on the topic of graphs of functions that belongs to mathematics course for O level and IGCSE students. In this session, we will discuss some quadratic graphs, and the quadratic graphs are the graphs of the equation of the form y is equal to ax square plus bx plus c. This is a quadratic equation, and this quadratic equation basically gives a curve like a parabola. So we will see this parabolic shape, and we will learn in the initial part this quadratic graphs. So some of the examples are given, and we will do exercise 25.1. Here we have the y is equal to x square plus 3x minus 7, and we have this x values, and we have to find this we have to complete this table accordingly. So we'll take the x square of this, and we will write take square of all these x, and we'll place it here. Similarly, multiply by 3x with this one, and we'll write it here, and like this 3 multiplied by 3 is minus 6, and minus 2 square is 4. So similarly with minus 7 added, minus 7 here, minus 7, minus 7, minus 7, and then we will add this x square plus 3x minus 7, and we'll write it here. So we put it here all, and similarly for the next questions. And let's start this from this one, and we have this minus 4, and this minus 4 is 16, and this minus 4 multiplied by 3 is minus 12, and this minus 7 is here, and we'll add this, and this plus 16 minus 12 and minus 7 is minus 3. So this y is equal to minus 3, which is equals to x square plus 3x minus 7. So we'll add this 3, and we will get this. Similarly for this minus 3, 9 square, and 3x multiplied minus 9, and minus 7 is here, and we'll add all these, and the resultant will be minus 7. Similarly for this one and for everyone. So we'll have these values. Similarly for this 2x square minus 8x, x square, and then 2 multiplied by 2, 2x square minus 8. So we'll add this, we'll place. Similarly for this question number 3. And now question number 4, copy and complete the graph y is equal to x square minus 3x, and this is all here, and we have to draw the graph. So we have to draw the graph. So we have x is equal to x square minus 3x, so it can be the other term, we have to make it a complete square. So making it a complete square, so we'll add this 3 by 2 square and subtract the same 3 by 2 square. So nothing added here. So this from here to here it becomes a minus b whole square. So we'll write a minus b whole square minus this terms left, so we'll replace it here. So x minus 3 upon 2 square minus 9 by 4. This is a standard form, and here we can see that this value will be 0, minimum value, because this is a square, so it will never be a negative value. For whatever the value, it will always gives a positive value, except at x is equal to 3 by 2, where it will be 0. So the minimum value of this square is 0. So at that point the y value will be minus 9 upon 4. So at x 3 upon 2, this y value will be minus 9 upon 4. So 3 upon 2 means 1.5, y is equal to 2.25. So we have this minimum value at 1.5. At 1.5, this is the minimum value, and we can see this by factorizing it. And y is equal to 0. So x square, we take the x common, and x minus 3. So x is equal to 0 and x is equal to 3. So the intersecting point is x is equal to 0 and x is equal to 3 when y is equal to 0. So at y is equal to 0, we have these 2 points. So the x-intercepts are this. So this is the minimum value, this is x-intercept, and all the values that is obtained in a table here is, this is x and this is y. So x and y are plotted on this graph like this. 1 2 3 4 5 6. So 6 values are plotted there. So this is all there, and so this curve is this. So we are already see that when we have this coefficient is positive, the curve always gives this kind of trend, here, like this, a happy face shape, like this, a parabolic shape. This is the minimum point. We always gives a minimum point. And here we have another graph, question number 16. Draw the graph for values of x from -1 to 6. So we -1 0 1 2 3, for different values of x we have obtained the value of y. So place this x here and x here and then 5, and we obtain this directly without going to our steps. So we have this value and the last row and first row. So from this first row and last row we have this, and we have plotted this, and we can see this, the minimum value is at 3, and we can also do the same as we did earlier. So from this x square minus 6x plus 5, so from this we can make it a perfect square by 3, adding 3 here, till now here, this, and this 5 is here. So this is complete square, and then minus. So this at x is equal to 3, we have this y is equal to -4. So that's the minimum value here. So this is the graph that we have plotted here, and from this table also. So this is in this graph. Question number 6, we have this y is equal to -x square plus 4x minus 3. So this coefficient is minus, so graph will be inverted graph. So here we have a maximum value. So by plotting it from -1 to +5 with a step of 1, so we have these values, and we see that the minimum values are these are here, and this is the maximum value, that is 1, which is here. So we have plotted it -x square plus 4x minus 3, and take this minus common here. So this x square minus 4x and this -3 is here, and now we have to make it a perfect square by adding +4 and -4 within this bracket, and this is same, and this is x minus 2 whole square, and this -4 and -3. So this is minus minus plus, so this is +4 and -3, and this is minus x. So this is minus x minus 2 whole square plus 1. So at x is equal to 2, the value of y will be +1. That is the maximum value that is shown here. This is +1 when x is equal to 2. So this is the maximum value we have plotted. In question number 7, we have draw the graph of this y is equal to x square minus 5x plus 2 for the values of x from -1 to +6. So -1 to +6, we have obtained these values for this y is equal to x square minus 5x, and this is plotted, and we can see that y is equal to x square minus 5x plus 2, and this is written as x, and we make this a perfect square by this method from here to here. This is this factors is further divided into 2 into x 5 by 2. So this 5 by 2 is added here, subtracted here, and this +2 is this. So this, or from this we have obtained this face, which is x minus 5 upon 2 square minus 25 upon 4 plus 2. So from this we have this minus 17 upon 4, and from this minus 17 upon 4, we see that when y is equal to 0, then this becomes x minus 5 upon 2 is equal to 17 upon 4. So this, when y is equal to 0, then this is this graph. So x is equal to 5 upon 2 plus minus 17 upon 2. So this is 0.44 and 4.56 are the intersecting values, like this and this here. This is 0.44 and this value is 4.56, and from this we see that the minimum value of this, it will be 0. So this at the minimum value of this x, this value, so this will be the minimum value. So here it is minus 17.4, which is minus 4.25. so this is x at x is equal to 2.5. This is the minimum value we have, that is minus 4.25, and we have plotted it here. So this is question number 7. The next question, the question number 8, draw the graph of y is equal to 2x square minus 5x plus 1 for values of x from minus 2 to 4. So find the values of x on your graph when y is equal to 0. So we have plotted all the values from minus 2 to 4, minus 2 to 4, and we have obtained these values, and this is the graph against x and y. So this is x and this is y, and we have plotted all these values here on this graph, and we can see from this graph y is equal to 2x square minus 5x plus 1. So we can equate it like ax minus b whole square plus c. This is ax, this is a is here, and we have open this square here in this bracket plus c, and from this we have this ax square minus 2abx plus ab square plus c, and here we can see this, we can compare this equation with this one, and we see this from x square, the coefficient is a, and here it is 2, so a is equal to 2, and 2 minus 2ab is equal to minus 5. This is minus 2ab, this minus 2ab is equals to this minus 5. So this is minus 5, so this is minus 5, and similarly this a plus a into b square and plus c. So ab square is the constant value, this is 1. So from this we have this a2, and then b is equal to 5 upon 4, and then c, placing a and b here, and the c is obtained as minus 17 upon 8. So this becomes this. So y is equal to 2, because this is 2 here, and b is 5 upon 4, so is here, and c is minus 17 upon 8, which is here. So this y is equal to c. So at x is equal to 5 upon 4, this will be 0, and y value will be minus 17 upon 8. That will be the minimum value, which is here. So we have these values, and this is the 9th question. Draw the graph of y is equal to 2x square minus 12x for the value of x equal to minus 1 to 7, and write down the values of x where the curve crosses y is equal to 5. So we have this value minus 1 to 7, and we have plotted everything here, and substitute the values of x and corresponding y values obtained, and from this we have plotted this curve. This can be done in a similar way as we did in the previous example, and y is equal to 2x square minus 12x, and we can equate it, and we draw it here, and then make coefficients compare, and this ab square plus c is here 0, so from c we have obtained, and this y is equal to this a here, and this b value is here, and then c value which is obtained here. So from this x is equal to 3, this will be 0, and y value will be minus 18, like this. So we have drawn this like this. So the curve is also very easy, and for that value, this is corresponding values for x when y is equal to 0. Y is equal to 0, we have one value is here, and one value is one value is here, and the other value is here, 6.39. Right. So this is that's all. So at y is equal to 5, we have to find the value at y is equal to 5 crosses. So because in this case, in the b part, we have to find the value of y is equal to 5. At y is equal to 5, we have to find the value of x. So at 5, at this value, this line is crossing, so we have this 1 point solution and the other one, and these 2 point solutions are obtained here. So we have equated it y is equal to not 0 but 5 here, and we have find the value of x corresponding to this y is equal to 5 line. So we have these two values 0.39 and 6.39. So at y is 5, at y is equal to 5, it is crossing this curve at 0.39 minus 39. This is minus 0.39 and this is 6.39. While at y-axis it is crossing 0 and 6. So this is all very important. And in the D part, when a stone is dropped from edge of a cliff, the distance d meter it falls, it given by the formula of d is equal to 5t square, where t is the time in second, and we have to find the different values. So we did it same here, and this is the same way that we solved. So we will discuss it sometime later, but in the next session we will discuss 25.2.